All right, so we're going to do what we call a longitude problem. So Herb is on an island in the Pacific. He determines it's 2 p.m. on his island, but it is noon in Hawaii at longitude 125 degrees west. What is his longitude? This is how I want you to do these problems. Works out perfect if you do this every time. I always put the sun over here on the right. Okay? Then you draw the Earth, North Pole sticking out. And then we're going to put Herb and Hawaii at their locations relative to the sun. So we know that the sun here, remember here, this is noon, this is 6, and so every 15 degrees is another hour. So if I go here, it is 2 p.m., so Herb is at 2 p.m. So remember, this is noon right here, 6 p.m. up here, so 2 p.m. is going to be about right here. So this is 2 p.m., that's where Herb is. Okay? Now, it's noon in Hawaii, so I'm going to put Hawaii right here. I'm going to put a volcano because Hawaii has volcanoes. This is Hawaii, and it's at noon right here. Okay? Well, I know where Hawaii is compared to England. That's what longitude is, 125 degrees. And in this case, that means that I go 125 degrees away, so I'm making this angle 125 degrees. That's 0 degrees. That's the prime meridian, and that angle to Hawaii is 125 degrees. That's what longitude means. But I want to know what the longitude of Herb is, so I want to know what this angle is. To do that, all I do is say, how many hours difference is it from 2 p.m. to noon? And when I do this, I say this is a 2 hours difference. And we already figured out that there's 15 degrees per hour. So 2 times 15 is 30 degrees. So that angle from Hawaii to Herb is 30 degrees. But we don't want that angle. We want the angle from 0 to Herb. So we take the whole angle. Remember, this whole thing is 125. We just take 125 minus 30, which is 95 degrees west. All right. I know you're saying, that looks a little tricky. Let's do another one. So this is another example. All right. It is 11 a.m. for Herb, but 3 p.m. in Miami, longitude 70 degrees west. What is Herb's longitude? All right, so in this one, we're going to do exactly the same. We're going to put the sun over here. We're going to draw the Earth. And then I'm going to put Herb where he is. Herb, it is 11 a.m. for Herb. So Herb, remember, straight at the sun is noon. So I'm going to put Herb over here. Draw a line to the center of the Earth. That's 11 a.m. for Herb. 15 degrees short of noon. And it's 3 p.m. in Miami. So let's draw Miami up here. Well, noon, 3 p.m. is going to be halfway between. Remember, 6 p.m. is up here. Halfway between the two is 3 p.m. This is Miami right here. Miami. And I know that Miami's longitude is 70 degrees west. So I go over here 70 degrees. So that angle is 70 degrees. This is where 0 degrees is. All right. I know what you're thinking. Maybe. the Earth is spinning this way, right? So from Miami, east is that way, right? If east is that way, why do I make my angle go 70 degrees this way when it says 70 degrees west? Well, you have to remember that the 70 degrees west is from England. So if I'm in England, over here, which way is east and which way is west? East is this way, west is this way. Remember, east is the way it's rotating. So I go 70 degrees west to get to Miami. So if it's west from Miami, you actually have to go east to figure out where 0 is. I always go to the left for anything that's west and you'll be okay. Or go counterclockwise. Alright, so that's 70 degrees. I need to know the angle in between here, and then I want to know the longitude for Herb, which is that total angle. Well, from 3 p.m. to 11 a.m. is 4 hours. And so I just take 4 times 15, or 60 degrees. Remember, there's 15 degrees per hour. The hours cancel, you're left with 60 degrees. Now in this case, I have 70 degrees is here, and I have this is 60 degrees, so the total is just going to be 70 plus 60. He's at 130 degrees west. Notice in this one, I added, but in this one, I subtracted. Why was there a difference? The difference is the time here. In this case, Herb's time is earlier than the reference point. In this one, Herb's time was later than the reference point. So it depends on which way they're flipped. That's why if you draw your picture right, it makes sense. So that's how you do these longitude problems. Okay. So far, so good.